My name is Paula Sanematsu. I'm a Senior Research Computing Facilitator at FASRC. In this training video, we'll discuss Rocky 8 changes that were implemented during the June 2023 maintenance.
Most software built on CentOS 7 will not work on Rocky 8. Software on Rocky 8 will be provided through HelmMod, our modules, and will include compilers, basic libraries, and a few software. Spec will be recommended for most software installs. Due to the OS upgrade, Singularity now is version 3.11, which allows users to build their own images on the cluster. For Julia, the best approach is for users to install their own copies of Julia in their workspace. For Python, it will be very similar to what we currently have on the cluster. But instead of using Anaconda, we'll be using MambaForge. For R, you can use install packages for most packages, and for complex packages, you can use Spec. For legacy CentOS 7 support, we'll have a Singularity container with the full compute node environment and CentOS 7 modules. CentOS 7 will not be maintained for the compute environment. Also note that Slurm support for CentOS 7 will be dropped with the next major Slurm upgrade. For HelmMod modules, we'll have compilers such as GCC, Intel, OpenMPI, and CUDA. We'll have basic libraries such as HDF5, GSL, NetCDF. We'll also have very common libraries like R, Python, Mamba, JDK, but customization will be left to the user through Spec. For example, if you need a certain library compiled with a specific compiler, then you can do that through Spec. Also, commercial software will be available through modules. For example, if you need MATLAB, you can do module load MATLAB, and then you can do the command module list to see the currently loaded modules. In addition, to search for modules, you can use the command module spider. In this example, we show the different GCC versions with module spider GCC. Also, you can search for a part of a word, such as module spider open, and it will list OpenMPI versions. Another command that you can use to see available modules is module avail. However, some modules are only shown if you load a specific module. For example, if you load Intel, then when you do module avail, you'll be able to see Intel MPI, Mapish, OpenMPI that were compiled with the Intel compiler. Spec requires a one-time setup by the user. You will have to clone the repo in your lab storage because that's better performance than your home directory. Then you will source Spec and then install packages with Spec. Be aware that some software can take a few hours to build. Then, after your Spec environment is set up, for a job submission, you will need to source Spec, load packages and software with Spec, and then run your code. I will show the steps in more details next. For the one-time setup, you first request an interactive job with the sllook command. Then you change to the directory of your lab storage where you would like to download the Spec repository. You can use the command git clone to download the repository. Then change directory to Spec, check out the appropriate release, and this is the command to source your environment. These are the commands that you can install Spec package. You can use spec install bizzip2, and that will install the latest version, or you can use spec install bizzip at a specific version, and you can also choose a compiler, spec install zlib at version, and then the %gcc at 8.5.0 that will specify a zlib specific version and a GCC specific version. After you have set up your spec environment and you would like to submit a Slurm job with spec, you will need to source spec within your Slurm script. You have to add this line dot and then wherever your spec is with the share spec set of env.sh file. This will source the spec environment. You can also substitute the dot with the word source. Then you will load all your spec packages that you have installed, and then you can run your code. All of these steps are also available on our GitHub page. You can go to github.com/FASRC and then click on user codes. You can click on documents and software and go to our main spec page. So our main spec page will have all the instructions for install and setup with a git clone, with how to check out a release, how to source your environment. And it will also have more details on how to download all the packages. With Singularity on Rocky 8, you can build containers from existing container in Singularity CE container library, from existing container in Docker Hub, from Singularity CE definition file on Scilab's cloud, and for the first time, any user will be able to build Singularity containers directly on the cluster. This is possible because Singularity CE version 3.11, along with proot, has enabled anyone to build images on the cluster. You can see specifics about how to build Singularity images again on our GitHub page. If you go to github.com/FASRC, click on user codes, click on Singularity containers, then you can see the different ways to build Singularity containers, from existing container in Singularity CE library, from Docker Hub, from a definition file on the cluster, and from a definition file on Scilab's cloud. All the information with all the steps is in our GitHub documentation. For Julia, we recommend that each user downloads their own copy. You can download in your lab directory with wget. Then you extract the file with the tar command to extract the tar.gz file. And after you're done, you have to export the path. In this example, Julia was downloaded in N, Holy Labs, Labs, JHarvard, Users, JHarvard, Software. So the path that I need to export is path, and then include the entire path, as mentioned above, as well as Julia-version/bin. This will allow you to type the command Julia, and Julia will be recognized. Again, all of our steps are in our user codes GitHub, and you can go to languages, and then Julia, and you can see the installation instructions down here.
Python on Rocky 8 will be available through module Mamba, which is short for Mamba Forge. Mamba will be replacing Anaconda because it's faster and more robust. You can see that for Python 3, you can do module load Python 3.10.9-FASRC01, and then when you do module list, both Mamba Forge and Python modules will be loaded. Python 2 is also available. However, Python 2 still uses Anaconda because it is not available through Mamba. When you do module load Python /2.7.16-FASRC01, then module list will list Anaconda 2 and Python version 2.7.16. Mamba and Conda commands are very similar, as you will see in this example. First, we recommend that you request an interactive job with the salloc command. Once you land in a compute node, then you first do module load Python/3.10.9-FASRC01. To create an environment, the command is mamba create -n for name, and my environment is the name of the environment. And here are some packages that I would like to install in my environment. Python 3.10, pip wheel. Once the environment is created, you activate the environment with the command source activate my environment. You can see that you are inside a Mamba environment when the environment name appears ahead of your command prompt in parentheses. If you would like to install additional packages inside my environment, the command to do it is mamba install and package name. Here I'm installing NumPy. If you would like to uninstall a package, the command is mamba uninstall and the package name. Once you're done with your environment, to deactivate, you can do mamba deactivate, and you can see that the name of the environment in parentheses is gone, so you're no longer inside the Mamba environment. All of these commands with more examples are also available in our GitHub page. Again, if you go to github.com/FASRC and go under User Codes, Languages, Python, and you click on Mamba, you will see all the explanations that we went through in this example with a lot more details. Mamba create, and this is how you will see the output. At the very end of our page, you can also see how to create Conda or Mamba environments in your lab space, which has a lower latency than your home directory. R has a few changes for Rocky 8. First, there is no need to set rlibs user, neither to unset rlibs site. rlibs user will be automatically set. FASRC will no longer have software such as UD units, GDAL, and GEOS available through module load command that were previously needed to install R packages. Instead, we will be using spec to install these R packages and its dependencies. A basic R module is available through HelmMod, module load R. However, whenever you install R packages with spec, R is also installed within spec. Note that these changes are only for those that use the command line interface. If you use RStudio Server through OpenOnDemand, our former VDI, then these changes will not affect you. Simple R packages that do not require additional software installs can be installed inside R. Again, we recommend that you request an interactive job with the command salloc. Then, once you land in a compute node, you load the module R with module load R. Then launch R, and you can install packages with the command install.packages and the package name. Here is an example for data.table. Finally, you can load the library with the command library data table. If the package that you need in R requires additional software installed outside of R, such as RGDAL or raster, you will have to use the spec to install those additional software. In R with spec, you have a one-time setup that consists of cloning spec repo in your lab storage because it's better performance than home directory. You source spec, and then you install packages with spec. Note that some packages can take a few hours to build. For a job submission, you have to source spec, load packages with spec, and then run your code. Installing R packages with spec. First, as usual, we recommend that you request an interactive job with the salloc command. To use your lab storage, you can change directory to your lab storage. Here we're using N, Holy Labs, Labs, J Harvard Lab, Lab, Software, and Spec. If you would like to see more details how to set this up, you can go to our GitHub page, github.com/FASRC, User Codes, Documents and Software, and Spec. We'll have instructions here on how to set up Spec. Once you have Spec set up, then you can source Spec with the command .share/spec/setup-env.sh. You can install R packages with Spec with the command spec install and then the package name. To load the package, the command is spec load and the package name. Once you launch R, you can simply load library rgdal. Again, you can see more details about how to install packages with R in our user codes page, and then go to Languages, R, and R packages with Spec. In this page, we have all the details of this presentation with more examples with packages glmnet, raster, rgdal, rgeos, rstan, surat, and sf. If you would like to install an older version of R, there is also an example with Spec. If your workflow absolutely cannot be upgraded to Rocky 8, we offer a last resort option using a Singularity container with CentOS 7. It has the same environment of compute nodes before the OS upgrade. It can load CentOS 7 modules. However, it cannot submit jobs inside the container unless you have a special setup. You can modify the CentOS 7 image by building a new container based on the CentOS 7 image. If you would like to use the image, you will have to be in a compute node to have access to Singularity. Again, all of our examples are further explained in our GitHub FASRC page. If you go in User Codes, Singularity Containers, CentOS 7, we have all the details of how to run Singularity with CentOS 7. How to get a shell, how to load modules, how to submit Slurm jobs. This is an example, a Slurm batch script. And also how you can modify the Singularity image. If you have any questions about this presentation, you can contact us via portal, email, or come to office hours every Wednesday from noon to 3.